Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math B4 variant 2 May-June 2019. Let's get started. The price of a newspaper increased from $0.97 to $1.13. Calculate the percentage increase. The percentage increase will be the increase, which is 1.13 minus $0.97 divided by the initial price, which is $0.97 times 100%. When we type this into the calculator, we get 16.5%. One day, the newspaper had 60 pages of news and advertisements. The ratio number of pages of news is to number of pages of advertisements equals 5:7. Calculate the number of pages of advertisements. In our ratio setup, we've noted the ratio of news is to ads, which is 5:7. When we add 5 to 7, we get 12. We know that the total number of pages of the news and ads is 60, and we want to find the number of pages for ads alone, which is what we are calling X. From here, when we cross multiply and make X the subject, this is what we get. When we type this into the calculator, we get 35. Write the number of pages of advertisements as a percentage of the number of pages of news. In setting up the percentage, the number after the of is the number of pages of news, which is 5. This number will be our denominator. And so we have the number of pages of advertisements, which is 7, divided by 5 times 100%. When we type this into the calculator, we get 140%. On holiday, Maria paid 2.25 euros for the newspaper when the exchange rate was $1 equals 0.9416 euros. At home, Maria paid $1.13 for the newspaper. Calculate the difference in price. Give your answer in dollars. Correct to the nearest cent. First, we need to convert 2.25 euros into dollars. So we set up the conversion ratio. The exchange rate is $1 equals 0.9416 euros. We want to find X, which is the equivalent in dollars for 2.25 euros. From this setup, when we cross multiply and make X the subject, this is what we have, which is equal to $2.3895. Now that we have the holiday price in dollars, the price difference will be $2.3895 minus $1.13, which is equal to $1.26 rounded to the nearest cent. The number of newspapers sold decreases exponentially by X% each year. Over a period of 21 years, the number of newspapers sold decreases from 1,763,000 to 58,000. Calculate the value of X. The keyword here is exponential, and so we need to apply the exponential formula to find X. The number of newspapers sold is decreasing with time, so we bring a minus here. The annual rate has been given as X%, and we want to find the value of X. When we make X the subject of the equation, this is what we get. Big A represents the final number of newspapers sold, which is 58,000. Small a represents the initial number of newspapers sold, which is 1,763,000. T is the time duration in years, which is 21. When we type this into the calculator, we get 15.0 rounded to 3 significant figures. Every page of the newspaper is a rectangle measuring 43 centimeters by 28 centimeters, both correct to the nearest centimeter. Calculate the upper bound of the area of a page. To correct the length and width to the nearest centimeter, we bring their dimensions, then plus and minus 1 centimeter divided by 2. We are interested in finding the upper bound of the area, and that will be equal to the upper bound of the length times the upper bound of the width. The upper bound of the length will be 43 plus 1 over 2 centimeters, and the upper bound of the width will be 28 plus 1 over 2 centimeters. When we type this into the calculator, we get 1239.75 centimeters squared. AC is parallel to FBD. ABC is an isosceles triangle and CBE is a straight line. Find the value of x. Base angles in an isosceles triangle are equal, and the sum of the angles in triangle ABC must add up to 180 degrees. So we have 2y plus 26 degrees equals 180 degrees. When we make y the subject, we get 77 degrees. AC and FBD are parallel. This means these two angles are alternate angles, and we know alternate angles are equal. Angles on a straight line add up to 180 degrees. So we have x plus y, which we found as 77 degrees, equals 180 degrees. When we subtract 77 from both sides of the equation, we get x equals 103. The diagram shows a circle with diameter PQ. SPT is a tangent to the circle at P. Find the value of y. When we look at the diagram, this angle is 90 degrees because the angle subtended by a diameter at the circumference of a circle should be equal to 90 degrees. We also see that each of these angles is 90 degrees because the angle formed between a diameter and a tangent should be equal. If this angle is 17 degrees, then when we subtract 17 from 90, we get this angle as 73 degrees. And if this angle is 58 degrees, then when we subtract 58 from 90, we get this angle as 32 degrees. Based on the alternate segments theorem, if we found this angle as 73 degrees, then this angle should also be equal to 73 degrees. The sum of angles in this triangle should add up to 180 degrees. And so we have y plus 73 plus 32 equals 180. When we subtract the sum of 73 and 32 from 180, we get y equals 75. The probability that Andre cycles to school is R. Write down in terms of R the probability that Andre does not cycle to school. The sum of the probability that Andre cycles to school and the probability that he does not cycle to school must add up to 1. And so to get the probability that he does not cycle to school, we simply subtract R from 1. So we have 1 minus R. The probability that Benoit does not cycle to school is 1.3 minus R. The probability that both Andre and Benoit do not cycle to school is 0.4. Complete the equation in terms of R. All we need to do is put the probabilities that each of them do not cycle to school in the brackets. So here we have the probability that Andre does not cycle to school, which is 1 minus R. And here we have the probability that Benoit does not cycle to school, which is 1.3 minus R. Show that this equation simplifies to 10r squared minus 23r plus 9 equals 0. When we multiply 1 minus r and 1.3 minus r, we have r squared minus 2.3r plus 1.3. When we move all the terms to one side of the equation and group like terms, this is what we have. To get this equation in the form specified in the question, we need to multiply through the equation by 10. 10 times r squared is 10r squared. 10 times negative 2.3r is negative 23r. 10 times 0.9 is 9 and 10 times 0 is 0. Solve by factorization. 10r squared minus 23r plus 9 equals 0. First, we find the product of 10 and 9, which is 90. Then we list the multiples of 90 in this form. From this list, -5, -18 gives us -23. And so we rewrite -23r as -5r minus 18r. When we factor out 5r from the first two terms, we are left with 2r minus 1. And when we factor out -9 from the final two terms, we have 2r minus 1. We can rewrite this as 2r minus 1 times 5r minus 9 equals 0. When we equate 2r minus 1 to 0, we get r equals 0.5. And when we equate 5r minus 9 to 0, we get r equals 1.8. Find the probability that Benoit does not cycle to school. In part 3b, we were given the probability that Benoit does not cycle to school as 1.3 minus r. This means the value of r cannot be greater than 1. Therefore, the probability that Benoit does not cycle to school will be 1.3 minus 0.5, which is equal to 0.8. The equation of a straight line is 2y equals 3x plus 4. Find the gradient of this line. First, we rewrite the equation in the form y equals mx plus c. To get this, all we need to do is divide through the equation by 2. This gives us y equals 3 over 2x plus 2. The coefficient of the x term is the gradient of the line, and this is 3 over 2. Find the coordinates of the point where the line crosses the y-axis. At the point where the line crosses the y-axis, the x-coordinate is 0. When we substitute x equals 0 into the equation of the line, we get y equals 2. The diagram shows a straight line L. Find the equation of line L. The equation of any straight line can be expressed in the form y equals mx plus c. From here, all we need to do is find the values of m and c and put them into the equation. To find the gradient m of the line, we need to pick 2 points on the line. In this case, we are using 0, 6 and 3, 0. By applying the gradient formula, we get m equals 6 minus 0 divided by 0 minus 3, which is equal to -2. C is the y-coordinate at the point where the line crosses the y-axis, and that is 6. Another way of finding the value of C is to substitute the value of m and one set of coordinates on the line into the equation. Hence, the equation of the line is y equals -2x plus 6. Find the equation of the line perpendicular to line L that passes through 9, 3. The equation of the perpendicular line can also be expressed in the form y equals mx plus c. The product of the gradients of perpendicular lines is -1. We've already found the gradient of line L as -2, and so we get the gradient of the perpendicular line as 1 over 2. To get the value of C, we substitute the gradient value and the set of coordinates through which the perpendicular line passes into the equation. This gives us C equals -3 over 2. Hence, the equation of the perpendicular line will be y equals 1 over 2x minus 3 over 2. A is the point 85 and B is the point -41. Calculate the length of AB. To find the length of AB, we apply the distance or length formula. This is what we get when we plug in the coordinates of A and B into the formula. When we type this into the calculator, we get 12.6 rounded to 3 significant figures. Find the coordinates of the midpoint of AB. To find the midpoint of AB, we need to apply the midpoint formula. This is what we get when we plug in the coordinates of A and B into the formula. 8 plus -4 divided by 2 is 2, and 5 plus 1 divided by 2 is 3. And so the coordinates of the midpoints are 2, 3. The table shows some values of y equals 1 over 2x minus x over 4 for x is greater than and equal to 0.15 and less than and equal to 3.5. Complete the table. To get the corresponding y value, we substitute the values of x into the equation. For x equals 0.2, we have 1 over 2 times 0.2 minus 0.2 over 4, which is equal to 2.45. For x equals 1, we get y equals 0.25. And for x equals 2, we get y equals negative 0.25. On the grid, draw the graph of y equals 1 over 2x minus x over 4 for x is greater than and equal to 0.15 and less than and equal to 3.5. The last 2 points have been plotted for you. So on the grid, we plot all the points in the table and connect the points with a smooth line. Use your graph to solve the equation 1 over 2x minus x over 4 equals 1 over 2 for x is greater than and equal to 0.15 and less than and equal to 3.5. To solve this equation, we need to draw the line y equals 1 over 2 on the grid. So when we draw the line y equals 1 over 2 on the grid and note its intersection point with the curve, we get x equals 0.75. On the grid, draw the line y equals 2 minus x. To draw this line on the grid, we need to know at least 2 points on the line. Let's pick some sample points. When we plug in x equals 0 into the equation of the line, we get y equals 2. And so we plot our first set of coordinates 0, 2 on the grid. When we substitute x equals 2 into the equation of the line, we get y equals 0. And so we plot our second set of coordinates 2, 0 on the grid. When we are done, we draw a straight line passing through the points. Write down the x coordinates of the point where the line y equals 2 minus x crosses the graph of y equals 1 over 2x minus x over 4 for x is greater than and equal to 0.15 and less than and equal to 3.5. On the grid, the line crosses the graph at 2 points. The x coordinates of these 2 points are x equals 0.275 and x equals 2.35. Show that the graph of y equals 1 over 2x minus x over 4 can be used to find the value of square root of 2 for x is greater than and equal to 0.15 and less than and equal to 3.5. What we need to do is substitute y equals 0 into the equation of the graph. When we do this, this is what we get. From here, all we need to do is make x the subject. The LCM for the two fractions is 4x. So when we multiply through the equation by 4x, we get 2 minus x squared equals 0. When we move minus x squared to the other side of the equation, we have x squared equals 2. When we take square root of both sides of the equation, we have x equals square root of 2. Expand and simplify x plus 10 times x minus 3. First, we take x in the first bracket and multiply it by the terms in the second bracket. So x times x is x squared and x times negative 3 is negative 3x. Now we take 7 in the first bracket and multiply it by the terms in the second bracket. So 7 times x is 7x and 7 times negative 3 is negative 21. Minus 3x plus 7x is 4x. And so our final answer here is x squared plus 4x minus 21. Factorize completely. 15p squared q squared minus 25q cubed. The common factor here is 5q squared. When we factor that out, we are left with 3p squared minus 5q. Factorize 4FG plus 6GH plus 10FK plus 15HK. When we factor out 2G from the first two terms, we are left with 2F plus 3H. And when we factor out 5K from the final two terms, we are left with 2F plus 3H. We can rewrite this as 2F plus 3H times 2G plus 5K. Factorize 81k squared minus m squared. We have a difference of 2 squares, so we can rewrite this as 9k all squared minus m squared. When we apply the factorization for difference of 2 squares, we can rewrite this as 9k plus m times 9k minus m. Solve the equation 3 times x minus 4 plus x plus 2 over 5 equals 6. When we multiply through the equation by 5, this is what we have. When we expand the brackets, 15 times x is 15x, and 15 times negative 4 is negative 16. When we group like terms, we get 16x equals 88. When we divide both sides by 16, we have x equals 5.5. Show that each interior angle of a regular pentagon is 108 degrees. We can find the size of an interior angle in a regular polygon using this formula, where n is the number of sides of the polygon. In this case, the polygon is a pentagon, and so n is 5. When we substitute n equals 5 into the formula, this is what we have. When we type this into the calculator, we get 108 degrees. The diagram shows a regular pentagon ABCDE. The vertices of the pentagon lie on a circle center O, radius 12 centimeters. M is the midpoint of BC. Find BM. When we take a look at the diagram, we see that we can split the pentagon into 5 triangles. And so angle AOB will be 360 degrees divided by 5, which is equal to 72 degrees. OA and OB are radii of the circle. This makes triangle AOB an isosceles triangle. Base angles in an isosceles triangle are equal. And so to find the size of one of the base angles, we subtract 72 degrees from 180 degrees and divide by 2. This gives us 54 degrees. The base angles in triangle AOB will be the same as the base angles in triangle BOC, and so angle OBM will be 54 degrees. The radius passes through the midpoint M of BC, and so angle BMO is 90 degrees. We know OB is a radius and its length is 12 centimeters. Now that we have these values, we can easily find BM by applying SOHCAHTOA. This gives us cos 54 degrees equals BM divided by 12 centimeters. When we multiply both sides by 12, this is what we have. When we type this into the calculator, we get 7.05 centimeters rounded to 3 significant figures. OMX and ABX are straight lines. Find BX. We know angle ABM is 108 degrees. Angles on a straight line add up to 180 degrees. And so to get angle BMX, we subtract 108 degrees from 180 degrees. This gives us 72 degrees. Now we can find the length of BC using SOHCAHTOA. This gives us cos 72 degrees equals 7.05 centimeters divided by BX. When we make BX the subject, this is what we have. When we type this into the calculator, we get 22.8 centimeters rounded to 3 significant figures. Calculate the area of triangle AOX. We can apply the area of a triangle formula, half AB sine theta in this case. OA is 12 centimeters. AX is AB plus BX. AB is the same as 2 times BM. We found BM to be 7.05 centimeters and BX to be 22.8 centimeters. This gives us the length of AX to be 36.9 centimeters. We know the angle between OA and AX is 54 degrees. When we plug in these values into the formula, we get 179 centimeters squared, rounded to 3 significant figures. The diagram shows two triangles, ABD and BCD. AD is 16.5 centimeters and BD is 12.4 centimeters. Angle ADB is 64 degrees, angle BDC is 53 degrees, and angle DBC is 95 degrees. Find AB. We've been given the angle opposite side AB and we know the other side length of the triangle ABD. So we can apply the cosine rule to find the length of AB. This is what we get when we apply the cosine rule to triangle ABD. AD is 16.5 centimeters, BD is 12.4 centimeters, and angle ADB is 64 degrees. When we type this into the calculator, we get 15.7 centimeters, rounded to 3 significant figures. Find BC. We get angle BCD by subtracting the sum of 95 degrees and 53 degrees from 180 degrees. This gives us 32 degrees. To find the length of BC, we apply the sine rule to triangle BCD. This is what we get after applying the sine rule. From here, we make BC the subject of the equation. When we type this into the calculator, we get 18.7 centimeters, rounded to 3 significant figures. The diagram shows a sector of a circle of radius 3.8 centimeters. The arc length is 7.7 centimeters. Calculate the value of y. The arc length formula is arc length equals theta over 360 degrees times 2 pi r. In this case, we've been given the arc length as 7.7 centimeters and the radius as 3.8 centimeters. Theta has been given as y and this is what we want to find. When we make y the subject, this is what we get. When we type this into the calculator, we get 116.1 degrees rounded to 1 decimal place. Calculate the area of the sector. The area of a sector formula is sector area equals theta over 360 degrees times pi r squared. We found theta to be 116.1 degrees and we know the radius is 3.8 centimeters. When we type this into the calculator, we get 14.6 centimeters squared, rounded to 3 significant figures. 100 students were each asked how much money $M they spent in 1 week. The frequency table shows the results. Calculate an estimate for the mean. The mean is sigma f of x, which is the total sum of money spent by the students, divided by sigma f, which is the total number of students. To be able to get sigma f of x, we first need to get an average amount for each of the given ranges. So for the first interval, the average amount is 0 plus 5 divided by 2, which is 2.5. Then we have 5 plus 10 divided by 2, which is 7.5. 10 plus 20 divided by 2, which is 15. 20 plus 30 divided by 2, which is 25. 30 plus 50 divided by 2, which is 40. And so for sigma f of x, we have 2.5 times 16 plus 7.5 times 38 plus 15 times 30 plus 25 times 9 plus 40 times $7 divided by the number of students, which is 100. When we type this into the calculator, we get $12.80 rounded to the nearest cent. Complete the cumulative frequency table below. The number of students who spent less than $5 is 16. The number of students who spent less than $10 is 16 plus 38, which is equal to 54. The number of students who spent less than $20 is 54 plus 30, which is equal to 84. The number of students who spent less than $30 is 84 plus 9, which is equal to 93. On the grid, draw the cumulative frequency diagram. We plot all the points in the cumulative frequency table in part B. Then we connect the points with a smooth line. Use your cumulative frequency diagram to find an estimate for the median. Half of the 100 students is 50. When we map 50 on the diagram, we get the median as $9.5. Find an estimate for the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. To get the upper quartile, we map 3/4 of 100, which is 75, on the diagram. This gives us $15. To get the lower quartile, we map 1/4 of 100, which is 25, on the diagram. This gives us $6. 15 minus $6 is $9. Find an estimate for the number of students who spent more than $25. On the diagram, when we map $25 from the horizontal axis to the cumulative frequency graph, we get 90, which is the number of students who spent $25 or less. Therefore, to get the number of students who spent more than $25, we subtract 90 from the total number of students, which is 100. 100 minus 90 is 10. The volume of a solid metal sphere is 24,430 cm cubed. Calculate the radius of the sphere. We've been given the formula for the volume of the sphere. In this case, we want to find r. When we make r the subject of the equation, this is what we have. From here, all we need to do is plug in the volume V of the sphere, which has been given as 24,430 cm cubed. When we type this into the calculator, we get the radius as 18.0 centimeters, rounded to 3 significant figures. The metal sphere is placed in an empty tank. The tank is a cylinder with radius 50 centimeters, standing on its circular base. Water is poured into the tank to a depth of 60 centimeters. Calculate the number of liters of water needed. The volume of the water is equal to the volume of the cylinder minus the volume of the sphere. The volume of the cylinder is pi r squared h, where r is 50 centimeters and h is 60 centimeters. We already know the volume of the sphere, which is 24,430 cm cubed. Pi times 50 squared times 60 is 150,000 pi. To convert cm cubed to liters, we divide by 1000 or multiply by 10 raised to the power negative 3. When we type this into the calculator, we get 447 liters, rounded to 3 significant figures. A different tank is a cuboid measuring 1.8 meters by 1.5 meters by 1.2 meters. Water flows from a pipe into this empty tank at a rate of 200 cm cubed per second. Find the time it takes to fill the tank. Give your answer in hours and minutes. The time it takes to fill the tank will be equal to the volume of the tank divided by the volume flow rate. The tank is in the shape of a cuboid, and so its volume is 1.8 times 1.5 times 1.2 meters cubed. We've been given the volume flow rate as 200 cm cubed per second. To convert the volume of the tank to cm cubed, we multiply by 10 raised to the power 6. The cm cubed cancels out, so we can have our answer in seconds. When we type this into the calculator, we get 16,200 seconds. To convert this value into hours, we divide by 3,600. This gives us 4 1/2 hours. To convert 1/2 hours to minutes, we multiply by 60, which gives us 30 minutes. And so our final answer here is 4 hours, 30 minutes. The diagram shows two mathematically similar shapes with areas 295 cm squared and 159.5 cm squared. The width of the larger shape is 17 centimeters. Calculate the width of the smaller shape. Since we are dealing with similar shapes, the ratio of the areas of the shapes should be equal to the square of the ratio of their corresponding lengths. We want to find WS, which is the width of the smaller shape. So we make that the subject of the equation. AS is 159.5 cm squared, AB is 295 cm squared, and WB is 17 centimeters. When we type this into the calculator, we get 12.5 centimeters rounded to 3 significant figures. The sequence of diagrams above is made up of small lines and dots. Complete the table. For the number of small lines, the difference between the terms increases by a constant difference, which is 2. And so to get the number of lines in diagram 5, we add 12 to 28 to get 40. For the number of lines in diagram 6, we add 14 to 40 to get 54. For the number of dots, the difference between the terms increases by a constant difference, which is 1. And so to get the number of dots in diagram 5, we add 7 to 19 to get 26. For the number of dots in diagram 6, we add 8 to 26 to get 34. For diagram N, find an expression in terms of n for the number of small lines. The sequence of numbers for the number of small lines have their differences increasing by a constant number, which tells us the sequence is a quadratic sequence. The nth term of a quadratic sequence can be expressed in the form an squared plus bn plus c. To find the value of a, we equate 2a to the constant difference, which is 2. This gives us a equals 1. To find the value of b, we equate 3a plus b to the first term in the first difference, which is 6. We found a as 1, and so we get b as 3. To find the value of c, we equate a plus b plus c to the first term in the sequence, which is 4. We found a as 1 and b as 3, and so we get c equals 0. When we plug in these values into the nth term formula, we get n squared plus 3n. Diagram R has 10,300 small lines. Find the value of R. In part B, we found the formula for the number of lines for any diagram N. In this case, we want to find diagram R, which has 10,300 small lines. So we have r squared plus 3r equals 10,300. When we move 10,300 to the other side, this is what we get. When we apply the quadratic formula to this equation, this is what we have. The value of r cannot be negative, so we ignore the minus. When we type this into the calculator, we get r equals 100. The number of dots in diagram N is an squared plus bn plus 1. Find the value of a and the value of b. The sequence of numbers for the dots is also a quadratic sequence. To find the value of a, we equate 2a to the constant difference, which is 1. This gives us a equals 0.5. To find the value of b, we equate 3a plus b to the first term in the first difference, which is 4. We found a as 0.5, and so we get b equals 2.5. We don't need to find the value of c since it has been given as 1. In this case, let's go ahead to find it. If our steps and values are correct, we should get 1. So to get the value of c, we equate a plus b plus c to the first term in the sequence, which is 4. We found a as 0.5 and b as 2.5, and so we get c equals 1. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.